Hello students, welcome to the classroom point. In today's session, we shall discuss the haloform reaction with exceptions. The reaction in which haloform is formed is called haloform reaction. Haloform means its general formula is CHX3, where X may be chlorine, bromine or iodine. If you put the chlorine here, it is called as the chloroform, which is a colorless liquid. If you use the bromine, it is called as the bromoform, which is an yellow liquid. And if you use the iodine, it is called as the iodoform, which is a yellow solid. The reagents used in this reaction are base with the halogen. So here the base maybe you can take this one as NaOH or KOH or calcium hydroxide, any of the base which is able to release the OH minus ion with the X2. And here we are not using the fluorine, we are using only chlorine, bromine and iodine. The reason for not using the fluorine is fluorine has more oxidizing power than the oxygen, so that fluorine oxidizes this OH minus ion to the oxygen, so that OH minus ion will not be available in the reaction. So when OH minus ion reacts with the halogen, it forms a hypohalide ion. So this combination also we can use in the reaction, or else we can use the sodium carbonate with the halogen. Now let's come to the reaction. In this reaction actually, let us take the methyl ketone CH3COR. When combined with the base in the presence of the halogen gives haloform, salt, halide ion along with the water molecule. Now here let us see the mechanism of this reaction. CH3COR when combines with the OH minus ion. OH minus ion preferably abstract the proton from this carbon, so that creates the CH2 minus ion. What is the reason for this OH minus ion to abstract the proton from the carbon? Let us see one important thing. Whenever a carbon atom is connected to an electron withdrawing group, so the electron withdrawing group withdraws the electrons from the carbon. So carbon gets the partial positive charge. To reduce its partial positive charge, carbon try to withdraw the electrons from the hydrogens which are connected to each. So as a result, hydrogen carbon bonded electrons will be located closer to the carbon, so that hydrogen gets the partial positive charge. So that whatever the OH minus ion we are using here, that OH minus ion can easily abstract the hydrogens that are connected to the carbon which is connected to the electron withdrawing group. And if this particular carbon is connected to the two electron withdrawing group, and now it is looking as a CH2, and the hydrogens are called as the active methylene hydrogens, because these hydrogens can easily be removed from the carbon. Why? Because now this carbon is connected to the two electron withdrawing group, so that hydrogen gets the more partial positive charge, so they can easily be attacked by the nuclear or base. So base abstract the proton from the carbon, so that uh, by the sigma electrons will be shifted over to the carbon, gets the carbon negative charge. This carbon it participate in the resonance and giving the invalid ion. The negative charge of this carbon attacks over the halogen, so that we get the CHX and one hydrogen. Here two hydrogens are there, no? That two hydrogens I have written like this, and we get the CH2X. And still two more hydrogens are there. So the reaction will continue to takes place till these two hydrogens are removed. So that's why OH minus and X will attack, followed by reaction with the halogen, so that this hydrogen will be removed. Later this hydrogen also will be removed by the reaction with the OH minus ion and halogen, so that all the three hydrogen atoms what we have taken initially are removed by the halogen. And this entire step till all the hydrogens of the CH3 are removed by the halogen is called as the halogenation. Afterwards, again base will attack over the carbonyl carbon. In this case, even if you see, if one more CH3 group is present in this side, then also this OH minus ion will attack over the carbonyl carbon. not abstract the proton from the CH3, like what happened earlier. The reason here is this CH3 CX3 is more electron withdrawing group, so that this particular carbonyl carbon gets the more partial positive charge. As a result, it becomes more electrophilic center, so that OH minus N can easily attack over the this particular area, so that carbonyl carbon and these pi electrons will be shifted over to the oxygen, so that we get this tetrahedral shape intermediate. Later this negative charge will come back and the CX3 will be the better leaving group than the OH, so that CX3 minus will be removed. Later this carboxylic acid releases the one proton to the CH3 minus, so that we get the CHX3, which is called the halo. So if you use bromine here, you will get the bromoform. If you use the chlorine here, you will get the chloroform. If you use the iodine here, you will get the iodoform. Now let us see what are the conditions for the molecules to show the haloform reaction, whether all the molecules show the haloform reaction or not. Now this is CH3CO compound. So the compounds which are having the CH3CO group, this is a G. G stands for it may be hydrogen or any alkyl group, alkyl or aryl group. So that the compounds with the CH3CO group all shows haloform reaction, saying thinking that there is a hydrogen or alkyl or aromatic group. Now, apart from this one, then this particular molecule, secondary alcohols, also shows the haloform, positive haloform reaction. Here G stands for again hydrogen or hydrocarbon group. How the secondary alcohols shows the haloform reaction means, secondary alcohols when subject with the base and halogen, this reagent also acts as the oxidizing agent, so that it oxidizes the secondary alcohol part to the keto group. The mechanism is the lone pair of electrons attacks over here and replaces the halogen, so that OX part will be formed. Later abstraction of the proton takes place and finally keto group will be formed, and from here onwards rest of the reaction is same. So in the earlier reaction here we have studied two types of these steps. One is the halogenation, second one is the hydrolysis, because we used the methyl ketone. But here we are using the secondary alcohol. In the case of the secondary alcohols, one more step we have to include before of those two steps, that is oxidation. So oxidation, halogenation and hydrolysis are the sequence of reactions in the case of the secondary alcohol group in the haloform reaction. Now apart from the secondary alcohol and methyl ketones and these compounds with the monohalogen compounds and geminal dihalides having the CH3 group connected to the halogen bearing carbon also gives the haloform reaction. In this particular case, first of all, here this molecule OH minus N, when you use it, undergoes a nucleophilic substitution reaction and replaces this one, so that we get the CH3CHOH G. Here again G means hydrogen or hydrocarbon group. So secondary alcohol group is formed, so that a second condition is fulfilled here, like a secondary alcohol, so that again the remaining reaction takes place. So when you use the halogens as the starting reagent, then you have to use the nucleophilic substitution reaction step also, followed by the oxidation, halogenation and hydrolysis. If you use the geminal dihalide, here nucleophilic substitution reaction 2OH minus N will remove the two of these halogens, so that CH3 COH OH and G, and here extra one hydrogen we put, we forgot that, that is not necessary because it crosses the valency of the carbon, and later there is a loss of one water molecule from these two, so that CH3 C double bond OG. So condition number one is fulfilled. In this particular geminal dihalides, oxidation step is not there, only nucleophilic substitution followed by a loss of the water molecule, halogenation and hydrolysis. And two amino alkanes, lactic acid, pyruvic acid, both are having the COH group, even though they react with the base and halogen, and they produce the haloform reaction. But which compounds gives the negative haloform reaction? The compounds in which C double bond O part means methyl keto part, which is connected to the any of these groups, means acids or acid derivatives, do not give the positive haloform reaction, they give the negative haloform test. The reason here is CH3CO, if in the place of the G dash, if you put the OH, it becomes the carboxylic acid, not the ketone. So even though here carboxylic acids are, these are exceptional cases. In this one, though carboxylic acid is there, carboxylic acid react with the base and base will not be available. And later OCH3, Cl, these are all the molecules which can easily react with the bases, and finally base will not available in the reaction. So these groups, if attached to the CH3CO group, will not give the any positive haloform test. Now let's see the exceptions in iodoform test. Iodoform means haloform reaction. The exceptions are, see, when you subject this particular molecule with the OH minus ion, this OH minus ion preferably search for the most acidic protons. Let us see where these protons are present. These are all the protons, hydrogens, and here also one hydrogen is there. So among all the hydrogens, 1, 2, 3, 4, apart from these two, so these four type of the hydrogens, this particular nitrogen bearing hydrogen is more acidic in nature. Why? Because this hydrogen is connected to the more electron withdrawing nitrogen. Later this nitrogen in turn connected to the two electron withdrawing groups, so that OH minus N preferably will be attacked over this hydrogen, so that OH will connect over here and negative charge will be formed here. This negative charge is more stable in the form of the resonance, so that we don't get the CX3 type of the part, like in the mechanism I had shown you here. This particular part CX3, if CX3 is not formed, then we don't get the iodoform or haloform reaction. So this particular molecule is unable to give the haloform reaction. Now let us see this particular molecule OH minus ion. So again you see the hydrogens, where these hydrogens are present. So these are all hydrogens. Here three hydrogens are present. So among these three hydrogens, this OH minus ion preferably attacks over this particular methylene group, giving the two iodines here, and these are connected to the active methylene group, two electron withdrawing groups. So we get this type of the molecule. You just see here. So after the reacting with the iodine, if you imagine these two iodines are connected to this particular carbon, and if OH minus ion try to attack now, this OH minus ion will attack over here, not over to this particular carbonyl carbon. Reason is this carbonyl carbon is more electropositive than this one, because it is connected to the electron withdrawing group. So it attacks over here, produce the negative charge. That negative charge will come back and removes this particular one. So here we don't get any CX3 type of the part, because this triplet is more better leaving group, so that this particular molecule is also unable to give the positive iodoform test. Now let us see this molecule. In this case, if OH minus is try to attack, here we can see three hydrogens, here one hydrogen, here again three hydrogens are there. Among these hydrogens, this hydrogen is more acidic. Why? Because this hydrogen is connected to the two electron withdrawing group. So OH minus will be directed over to this carbon atom, so that OH will not attack any of these carbon atoms, so that this molecule also do not give the positive iodoform test. Now let us see this particular molecule. So in this molecule, in the case of the in the form of enolic form, these two compounds do not respond to the iodoform test, but when they are in the keto form, they respond to the iodoform test, iodoform or haloform test. See now, haloform, these are the diketones, these are the two hydrogens. So these two hydrogens are replaced later by two iodine, so that iodine will come over here. Later OH minus ion will attack over here, and it will be tetrahedral molecule will be formed. Later this will be disconnected, and Ci2 minus will be formed. This I2 minus will attack over one more iodine. I'll write here as the place is not available, so that the molecule structure will be like this. This is double bond OH, here double bond O, to iodine, here negative charge will come. This negative charge will attack over the one more halogen and it will give the one more iodine. Now this OH minus attacks over this one, this particular chiral carbon, carbonyl carbon, and molecule will be like this. O minus OH. Now this is iodine Ci3. Now Ci3 is more better leaving group than the OH minus, and so that I3 minus will be formed. This OH will lose one proton to the Ca3 minus, and finally CHI3 will be formed. Hence, this molecule responds to the iodoform test. So this molecule gives the positive iodoform test, and similarly, this molecule also gives the positive iodoform test in its keto form, not in the enol form. So fluoroglycinol and resorcinol both gives the positive iodoform test. Now let us see this particular molecule here. NO2 CH3 is connected to the strong electron withdrawing group like CO group. So this also gives the positive iodoform test. And in this case, when this molecule try to attack with the OH minus N, we can see a different type of the hydrogens, more positive, more electronegative, sorry, more labile hydrogens are present. So among these hydrogens, this is the more acidic proton. Why? Because it is connected to the two electron withdrawing groups, cyanide and this particular species, so that here it attacks over here, and this OH minus N will not attack either here or here. And once this negative charge is formed, it gets resonance stabilized. So this is reason why this molecule is not able to give the positive iodoform test, because base is busy with reacting with this type of the hydrogen. Now come to this particular molecule. In this particular molecule, we can see uh, different type of the hydrogens here. They are, one is CH3 here, CD3, and here CH2, here CH3. Among these hydrogens, here these two hydrogens connected to the electron withdrawing keto group, but electron plus I group is also there, so that if you remove any hydrogens here, the negative charge will be formed. That negative charge becomes destabilized because of the plus I group connected to it. And these two CH3 and CD3 are directly again connected to the C double bond O group. So these are more acidic, and here no plus I group is there. But in this, CD bond is stronger than the CH bond, hence it is easy to break this particular bond. And CH3 CO group is there, so that it gives the positive iodoform test from this side, not from here. And in this particular molecule, let us see the when this is subject with the OH minus N. OH minus N always search for the acidic protons, so that let us see where these acidic protons are present. These are all acidic protons only, here no hydrogen, like this. So among all these, then which proton will be attacked? These two hydrogens will be attacked by the OH minus N, because this is active methylene group that is placed between the two keto groups. So we get the positive iodoform test from this area, not from any of these. So this also gives the positive iodoform test. And the last molecule is, let us see this particular molecule. In this particular molecule, if it is subject with the OH minus ion, let us see where more acidic protons are present. These are all acidic protons only. Among these acidic protons, this is the strong acidic proton, because nitrogen again connected to the electron withdrawing CF3 groups, and nitrogen is a more electronegative element, so that OH minus and busy in attacking over this hydrogen, not any of those, so that you don't get the CX3 part, so that this will not give the positive iodoform test. So these are the questions which were asked in the previous examinations. Most of the time they are asking the exceptional cases of the haloform reaction, which of the following compound gives, which are the following compound not giving the haloform reaction. Hope you understand my explanation. If you understand, please do not forget to like, subscribe, and share this video to your friends also, and comment your opinion. Thank you.